Today we're going to discuss the Lab 2 of CSE 312. In this lab, we will design some combinational logic circuits. To design these circuits, we will require to use the Logisim software, which can be found in this link that we have mentioned here. The primary objective of our lab is to design combinational digital circuits using logic gates. We need to understand the basic design considerations in designing combinational circuits. We also have to identify the required chips to implement these design circuits. We will also test different combinational circuits. As we do this lab, we will also get familiarized with the TTL chips and the datasheets. We will try to develop an engineering understanding about which datasheet parameters to use. We will also try to understand a simple tool like Logisim to use and create digital circuit design and simulation. We will also try to use this tool to optimize our design for larger gates. Some common instructions for this lab. The software we're going to use is called Logisim and it can be found in this link. We can also use the documentation from this link here. A recent version of the Logisim is mentioned in the GitHub link that we will use. So if we open this link in Logisim Evolution, we will see the download links are appearing here under the platform specific packages. So we're going to use 3.7.2 in our lab. This link has all the different builds. For example, it has RPM builds for CentOS based operating system. It has DMG for the macOS based system. It has MSI file for the Windows system. It has .deb or Debian file for Ubuntu based system. It also has the .jar file which we are going to use because that is for the Java based system, and this file should be compatible with all the operating systems mentioned above because Java is a software that is available in all these operating systems. After we have downloaded this Java file .jar file, we should locate that and we should go to that folder using terminal. So here we have that file Logisim Evolution 3.7.2 all.jar. To run this file we will need some Java. For example, in this machine I have Java OpenJDK version 17. So you might be required to use a different Java version based on whatever your operating system is, but update your operating system's Java application. If you do not have anything, you need to install Java runtime environment to the latest version. To run this program, you need to type Java -jar and then specify the Logisim file name. It will open up this like this. It will have a Logisim window. To design a very simple logical function or combinational circuit using Logisim Evolution or any Logisim, we will need some basic pin. So for example, we have a pin here. These are just switches. So we can use, for example, 2 switch. We can name these components. For example, we want to name this one to something like A and press enter. It will name it A. We can also double click on the component and then type the name. So this is putting some label beside the components. Let's design a logic gate, our very favorite AND gate. So let's have this AND gate, which is a 2-input AND gate here. We can find different logical components on the left side. For example, here are the gates. We have plexers. We have different other input output units. For example, we can use the LED as an output unit. Now it's time for connecting all the components. So we have to go to wiring mode. We can connect all the pins using these wires, and we can break the wire to create a 90-degree angle at any point by clicking on the left mouse button. So we have connected A with the AND gate. Now let's connect B with the AND gate. And then we can connect the output of this 2-input AND gate with the LED. As we can see, the LED is off as the color is very darker here. So if we want to experiment with different values of this pin, we can, or push switch, we can click on this hand icon and click on either of these buttons. For example, if I click on A, we can see that the value has changed to 1, which shows high value, and this wire also has high voltage now. But the LED is still 0 or off because we do not have both these A and B as high. If I turn on B also, Then we can see the B also turned high, the voltage is higher here, and then the output is also high, and finally we have our LED lit. So the LED has turned on and as high voltage as we can expect from the AND gates. In Logisim evolution, we can also see these menus, the different small gates here, which are frequently used. Different versions of Logisim might or might not have these options. We can save this project, we can export images, we can export the project, and we can also simulate this with different logic if we want, and we can also create timing diagrams from this Logisim evolution tool. Let's get back to the lab. So this Logisim tool we'll be using is from this GitHub repository. You can use the basic Logisim version, which is also very similar, but it might not have all the functionalities mentioned in the Logisim evolution. You have to use Logisim based tool to solve all these problems. Will be required to use gates, LEDs, 7-segment display, push button, memory, clock, different tools. You can print the drawn circuits from there. You can use pin and probes to identify your input and output. You should run a parallel wires called bus for all the input variables and their inverses, and then tap this to the feed of the input of the gates, and it is possible to mark the wires and switch the names switches with names. You should have those names beside the different wires and switches. Some useful resources are the Maurice Mano's textbook that is mentioned in the syllabus, also the Logic and Compute Design Fundamentals. It should be available in Tamu library. You can read about the TTL logic. You can read about the 74xx series logic family. You can find out what particular 74xx series logic gate you need. You can find out the datasheet, and also you can find out the datasheet about the 7-segment display. For problem 1, you need to solve this function f equals a naught bc plus ab naught plus bc naught. You do not need to simplify this function. Just use this function as it is and implement this in the Logisim using very simple 2 input and 1 input gates as required. For the second problem, you need to find out which logic gates you need to use to implement this in real life. So you have to use 7/4 series logic gates. There might be some other logic gates available, but you need to use 7/4 series only. You need to calculate the delay performance for these logic gates. If you have used 74FXX or 74LXX, different type of circuits, you will have a different data for this. You need to find out the switching characteristics from the data sheets of these specific ICs. You need to write down the datasheet parameter that you have used to calculate the delay for each ICs in your design. You need to write down the exact number of ICs of different types that you have used to implement this circuit in Logisim. The circuit delay would be the delay of the longest path in your circuit from input to output. For example, in our case, it is from A to LED or from B to LED, because both the paths are similar. If there are multiple paths, you should calculate the longest one, not the multiple one, right? You should calculate the longest one. In the data sheet, the delays are reported for individual gates, so you need to find out the individual gates. For example, in our case, we have used this AND gate, and to find out the AND gate corresponding IC number, you need to go to this link, the list of 7/4 series XS logic gates. So let's open this one, and if you try to find out the AND gate, which should be very close here, this is 74X08. It has quad 2 input AND gate. Since we're using 2 input AND gates, this should be fine. The corresponding datasheet can be found here. So this is example IC from TI. If you're using a different IC, you should have a different datasheet, and that should have a different characteristics completely. But if we follow this one, you should scroll down and find out there is a switching characteristics here. For example, in our AND gate, if we want to find out the switching characteristics parameter TPLH, that means the propagation delay for low to high, we have a typical value of 17.5 nanosecond in an ambient temperature of 25 degrees Celsius at 5 volt VCC. If we want to find out the propagation delay from high to low for both input A and B to the output, at typical condition we have 12 nanoseconds and maximum 19 nanoseconds. For our purpose, we will use the maximum value of propagation delay. In this example, since we are using a low to high scenario, we should be using this propagation delay for low to high, that's the first one, at the maximum result, that is 27 nanosecond. So our circuit, which has only one AND gate, only one 2-input AND gate, that can be implemented by this 74X08 IC from Texas Instrument, and that has a switching characteristics of maximum 27 nanosecond propagation delay. So the circuit delay of this circuit should be 27 nanosecond as well. So you have to calculate the circuit delay for this particular function. For the second problem, you have to design a real life scenario. Here there are multiple cars, and each car of the MTA, which is the Metropolitan Transport Authority of the New York, they have a subway transport, and in this subway there are 7 subway cars and 1 motor car, so 8 cars in total. You have to find out if there is any of this switch in out of these 8 cars is pressed. To do this, there are 8 switches in this car. For example, there is a switch in car 0, switch in car 1, and up until we have a switch in car 7. So you have to encode this data using an encoder, and this encoder should encode the data for a decoder, and this decoder should send this data to a 7-segment display connected at the driver's dashboard. You should be able to see the 7-segment display, circuit details, encoder details, decoder details in the links given above. For the problems, you need to identify the design parameters, that is the number of switches that will be required, the number of bits and wires that is required for the data bus, that is here, the size of the encoder and the decoder, whether it requires 2 input 1 output or 4 input 1 output, or what number of input what output, you need to find out that, and the same information for the decoder. You need to find out the 7-segment LED display datasheet. There are multiple of them. You can find out from the link given in the PDF, or if you find out something else in Google search or some other search engine, you can add those in your PDF as well. Add the link of that so that we can also read the same 7-segment LED display datasheet. You have to design the encoder and decoder using basic logic gates. So there are ICs which have implemented this encoder and decoder. So if you take a look at these 7400 ICs, there should be some ICs which already have encoder and decoder implemented, but you now need to implement this using basic logic gates and incorporate the same using the same system into Logisim. So in Logisim, you have to design an encoder and decoder and some switch like 0 to 7 and then 7-segment display. You need to submit your design with a brief text explanation and description on how well it should work. You must explain the working of your system to get full credit. Now for the last problem, you need to find out whether it's possible to replace this encoder decoder circuit with any specific ICs. If it's possible, then you need to find out which ICs can be used to optimize this design. You need to explain whether this IC based design or basic logic gates based design will perform better or worse, and then how much it will perform better or worse. So you have to explain those as well. So these are the basic information for lab 2. If you have any question, feel free to ask during the class or at office hour. Thank you.